Hello, good afternoon, everybody. My name is Vishwadeep, and I welcome you all on Unacademy Computer Science channel. This is the channel where you find your computer science problems solution, including your semester exam, including your gate exam preparation, including your placement preparation, or machine learning or data science or related problems also. So this is a complete package we are providing you for your computer science solution. In this particular session, I am going to talk about the previous year gate questions on the memory organization. Yes, on computer organization architecture course, memory organization is one of the really important topic, and from that particular topic I have chosen the previous year gate questions, and we are going to solve all those gate questions in this particular session. What is the specialty of this particular session? I will not only provide you the correct answer, but I will provide you the solution, and specifically I will provide you that if such kind of a new question comes in your exam, then how you are going to think about it. So it's more of a concept through question kind of a session. So without any failure, watch till the end and you will learn a lot from this particular session. Okay, so before we go further and before we study further, let me introduce myself first. My name is Vishwadeep. I have written the GATE exam multiple times, and this is my rank in final year. I have written the GATE apart from this also with the rank 119, 440, 682, 2. I went for my masters to IISc Bangalore, another masters from BITS Pilani in data science. Overall, this much experience I am having, and you can see these are the courses I am dealing with on Unacademy's platform. Unacademy is India's largest learning platform, and you guys are having opportunity from my team so that you can learn a lot. One of the opportunity is on Unacademy's platform for free is the special classes. Every educator takes so many free special classes for you guys so that you can learn a lot. You do this particular thing, go to unacademy.com or download Unacademy Learners app and go to my profile. Over my profile, you will be having the special classes. All these special classes are absolutely free. But to unlock the special classes, you need to use a code. Of course, all is free. Nothing you will have to pay, but you need to use a code. This code, VDEEP10. If you use this particular code, you will unlock all the free classes, all my free content on Unacademy's platform. And apart from that, if you are going to go for Unacademy and if you will be following my profile over there, you will be getting the notification of all my live classes. Plus, you will be able to achieve, or you will be able to watch my live classes, live interactive live classes. Plus, you will be able to watch all my previously taken live classes in recorded mode. If you want my all previously taken special classes in more organized as a playlist view, then you can go to this particular URL. On this particular URL, you will be having all my previously taken special classes, and all those special classes are in more organized manner. If you guys want to have a free test series, we have a free test series also for you guys. This is the free test series, and enroll for it and solve the quality questions in more and more organized way. Now, one and only thing which always we try to talk about is your career is very important part of your life, and that particular career should be given more and more priority. You cannot take it very lightly. To make your career on the track, we provide a platform over there. You can prepare for your GATE and EAC exams up to a highest level of preparation, and that particular platform is Unacademy Plus. This particular platform provides you the batches for your preparation, a closed environment for your preparation, a motivated environment for your preparation, so that you will always have the preparation going on with the highest level. You don't carry any doubts. You don't waste your time to solve the doubts. You don't waste your time to find out the best content. You don't waste your time to understand a small concept in a lot time. So all these things solution you can provide or you can have on this particular Unacademy Plus platform, and this platform provides you live classes, interactive classes. If you miss any live class or if you want to watch again the live classes, you can watch as many as times all those live classes in the recorded mode. You will be having weekly tests, you will be having doubt solving, and so many benefits of this particular Unacademy Plus subscription. This particular subscription you will have to buy, but there is a good news, and the good news is that particular subscription you can get in the discount if you use the code VDEEP10. This particular code is not just for the discount. This particular code is for lot of benefits. One of the benefit is what? You'll be getting discount. Another benefit is you'll be getting my mentorship if you use the code for your subscription, and you will get a particular connection made from your preparation to my team's effort. There is a team, that particular team is working a lot. That particular team consists the educators who have cracked any kind of some kind of exam, competitive exam, PSUs, NET, GATE or something. So all the educators are having a great experience up to around 10 years of teaching, and plus all the educators have cracked any of the competitive exams, so you can rely on that particular team. So if you want to trust on my team, and if you want to have a connection with my team, if you want to trust on my team, use the code and get your subscription done. This subscription you can buy in 24 months, 18 months, 12 months, 6 months, 3 months and 1 month also. So if you are preparing for GATE 21, you can take last month subscription and you can have the last time boost. If you are preparing for 22, 23, start as soon as possible so that you will be having your best preparation out of the remaining time. If you guys want to have another type of subscription in which the headache of preparation strategy will be ours means we will be giving you a personal coach from Unacademy side, and that particular personal coach will give you preparation strategy, will give you study planner, will give you booster sessions, will give you personalized test analysis, and will be given to you some notes and practice sets. If you want iconic subscription, that subscription has all the facility of Plus, Unacademy Plus, and apart from that this personal coach facility, and that particular subscription also you can have in the discount if you use the code VDEEP10. This iconic subscription comes only in the 12 months and 24 months package, but the thing is, if you are sincere enough for your GATE preparation, if you are sincere enough for your career, then you should start your preparation as soon as possible, maybe today, maybe now, as soon as possible with the highest level of the commitments. Okay, so if you are ready for the session, then we will start the session. But remember this code VDEEP10 for all the subscription and unlock. You need to use this particular code VDEEP10. स्वागत है आप सभी लोगों का जो भी यहाँ पे प्रेजेंट हैं उनका, और हम स्टार्ट करेंगे सेशन. बट बिफोर दैट आई नीड योर एनर्जी, आई नीड योर सेइंग यस, रेडी, यू आर रेडी फॉर लर्निंग, देन वी विल स्टार्ट द सेशन. जल्दी से टाइप कर दो कमेंट बॉक्स में यू आर रेडी, 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 एंड देन वी विल स्टार्ट. फाइन. So here it is, the very first question of the day. Very easy, very simple. Which of the following statement is true? ROM is read write memory. No, it's not true. ROM is read only memory. PC program counter points to the last instruction that was executed. No, it points to the next instruction's address. Stack works on principle of LIFO, last in first out. Yes, that is true. And the last one, all instructions affect the flag. No, false. All the instructions do not affect the flag. Most of those instructions only affecting the flag which are performing ALU operation, and some specific instructions are there which are directly operating on flag. हर एक इंस्ट्रक्शन फ्लैग्स या स्टेटस रजिस्टर को अफेक्ट नहीं करता है. दिस इज अ वेरी स्पेसिफिक क्वेश्चन ऑफ Microprocessor, nowadays microprocessor is not there in our syllabus, but still a small piece of information, I guess you can remember that. चलिए आगे बढ़े, अगला क्वेश्चन सॉल्व करें. अगला क्वेश्चन बहुत इजी है. I will explain you the example. I will explain you the method also how to solve such questions. ROM is used to store the table for multiplication. So there is a memory, there is a ROM which has to store a particular table for multiplication. Now what is the table for multiplication? Okay, मैं बताऊंगा. अरे मैं बताएगा रे बाबा, तुमको थोड़ा सा पेशेंस रखने का. 2 8-bit unsigned integer, multiplication of 2 8-bit unsigned integers. First of all, you need to understand that if you are multiplying 8-bit का number into another 8-bit का number, then you will be having a result of how many bits? The result of this multiplication will be of just double 16 bits. ऐसा कैसे? ऐसा कैसे? Okay, let's take a simple example. Suppose you have two values of 4 bits each. 4 bit each. Multiplication of 4 bits each value can have a result of what? चलिए डेसिमल में सीखते हैं. डेसिमल में सीखते हैं. रिमेंबर व्हाट आई टोल्ड, 4 bit value. 4 bit value, what is the maximum value which you can represent using 4 bits? 15. 1111 into 15, 1111. 15 into 15 is 225. 225 you can represent with how many binary bits? Answer is 8 bits. So 4 into 4 bits ka input multiplication can be represented in 8 bits maximum. So we are having here, instead of 4 bits, we are having 8 bits. So if you have two 8 bits values, if you are multiplying those 8 bits values, then the result will be of 16 bits. That's a single kind of information. Now let's go for the next one. I am talking about this. Question says you need to store the table for multiplication. अब ये table for multiplication का मतलब क्या है? You should take two values, let's say A and B. One is value 8 bits, another value of 8 bits. You need to store the result for every combination of 8 bits into every combination of 8 bits. That is the multiplication table. सारे combination 8 bits के multiplied by सारे combination 8 bits के आपको store करने को रहेगा. तो if you have all the combination of 8 bits, 2 power 8, and all the combination of 8 bits, it's like first result will be 0 into 0, second result will be 0 into 1, third result will be 0 into 2, then 0 into 4, 0 into 6, and such kind of 0 into the last one. I mean 2, 3, 4, 5 सब कुछ up to 0 into 255, then 1 into 0 to 255, then 2 into 0 to 255, 3 into 0 to 255, such kind of so many results you are going to store in the table. चलिए अगर इतना समझ में आया है आपको, तो can you tell me in this particular ROM chip how many number of results you are storing? Number of results, how many number of multiplications का result you are storing? So number of results you will have to store for 2 power 8 into 2 power 8, and each result is of how many bits? 16 bits. That's why the table size required is equal to 2 power 16 cross 16 bits का table. I hope you got it. Everybody, welcome everyone. Welcome whoever have joined little late. If you haven't liked the session को like कर दीजिए. और 2 power 16 different results you are storing, and each result is of 16 bits. My 2 power 16 I can represent as 64k cross 16 bits का table you will need to store this multiplication table. If suppose the same thing I will ask you as a generalized way, suppose you need to store multiplication table of two n-bit unsigned integers, n-bit unsigned integers, so in general way, what will be the formula of the memory size required? In general, for n-bit integers, my answer should be 2 power 2n number of results cross 2n bits of each result size. क्या ये क्लियर है? क्या ये क्लियर है सबको? Are you clear about this? Can you confirm this? Are you clear? 8 का है तो 2 power 16 2n into 16 bit का result. Got it everybody? Everybody? अरे बांगड़ू बोलने का रे बाबा, समझ में आया कि नहीं आया रे? चलिए another question, very easy. Which of the following is not a form of memory? Instruction cache is a form of memory. Instruction register, yes, it's a form of memory. Instruction opcode is not a memory. In translation look aside buffer, of course it's a memory. TLB. So C is the correct answer. C is not a form of memory. Instruction opcode is not a memory. क्या बात है, इतनी क्विक आंसर आ रहे हैं, क्या बात है, अमेजिंग अमेजिंग अमेजिंग. चलिए अगला क्वेश्चन ये रहा आपके कंप्यूटर स्क्रीन पर, बहुत ही इजी क्वेश्चन है. हाउ मेनी 32K क्रॉस 1 रैम चिप्स आर नीडेड टू प्रोवाइड अ मेमोरी कैपेसिटी ऑफ दिस? So if you have solved such kind of questions, it's very simple type of question in which number of chips will be this much. Total capacity 256 kilobytes divided by one chip capacity, which is 32K cross 1. चलिए अगर आपको ये नहीं समझ में आया तो मैं एक सिंपल सा एग्जांपल दूंगा, आपको समझ में आएगा. लुक एट दिस, लुक एट दिस, लुक एट दिस. आई विल गिव यू एन एग्जांपल, वेरी सिंपल वन. Suppose you want to construct 8 byte or 8 gigabyte of memory, 8 GB of memory, but you have the memory chips of only 2 GB each. 2 GB ka chip you have and you want to construct the memory capacity of 8 GB. What should be the number of chips required? How many number of chips you will put together to have 8 GB total capacity if you have the chip of only 2 GB each? Your answer should be what? Type down in the comment box. Type down in the comment box, your answer should be what? How many chips? How many chips? 4 chips? Fine. How did you get it? How did you get it? 8 GB total capacity divided by 1 chip ka capacity. Answer is 4. Same thing is asked here. Same thing is asked here. This is the total capacity you want. But you have chip of this much size only. Then how many number of chips are required? So I have written the formula, this. But the problem here, ये cross 1 क्या है? Bit or byte? The problem here is this cross 1 is what? Bit or byte? If I'll take it as byte, some other answer I'll be getting. If I'll take it as bit, then some other answer I'll be getting. So in this particular case, you need to know a simple piece of information, and that piece of information is very easy, that if nothing is mentioned, the default storage unit, the default unit for storage is equal to bits. याद रखें ये चीज, अगर आपको याद रहेगी, you will be able to understand cross 1 is bits. Convert this bytes into bits. It becomes 256K cross 8 bits divided by 32K cross 1. Why I have written this 8 bits? Just because 1 byte is equal to 8 bits, you know. K to K cancel, 256 is 2 power 8 divided by 2 power 5, which is 2 power 3. Answer is 8 into 8, 64. This calculation is very easy. Answer is 64. But अब बात यहां आती है कि सर अगर ये इंफॉर्मेशन नहीं मिलती हमें तो क्या हम ये क्वेश्चन सॉल्व कर पाते करेक्टली? If you did not know this particular information that default unit is bits, if nothing is mentioned, you will have to use bits, then what you will do in that case? क्या ये क्वेश्चन आप सॉल्व कर पाते correctly? If you would have taken this as bytes, your answer should have been 8, and that will be wrong. This 2009 was the first time I have appeared in the GATE exam, and I will share my own experience with you guys. Experience was very easy. Look at this. Experience is very easy. What I was having, my experience was this. Look at this. My experience is like this. When I was going through this particular question in 2009, I was in third year and I was not sure that what is the default unit of the storage, bits or bytes. If I will take byte, I will be going with answer A. If I'll be taking as bits, then I'll be going with option C. Now, which one is correct? I didn't know. Which one is correct? I didn't know, and I was not knowing that bits is the default capacity. Now, what happens is, right? What happens is, very simple concept I have used. See, if here is bytes, just because it is bytes they have written. अगर ये byte है तो लिखा है. यहां भी अगर byte होता तो लिखा होता. यहां भी अगर byte होता तो लिखा होता. If here this 256k is bytes, they have written it. If bytes also here also, then they should have been written it is byte. If it is not written, means it is not byte, hence I have taken it as bits. That was my dynamic thinking which I have used over there. So what is the learning out of this particular experience? I want to tell you that sometimes in the exam it will definitely happen that one small concept you will not know, but still with your dynamic thinking, but still with some kind of improvisation, with some kind of analogy, you can solve the question correctly. And such kind of, if you can solve 2 or 3 questions without knowing perfectly about that topic, still you can get better marks. So such kind of ability also required in the GATE exam to succeed. Hence, if you feel like ki I have completed entire syllabus, I have solved all the previous GATE questions, I have solved this much booklet, that much booklet, this is not enough. That is not enough. Knowing everything is not enough. You need to be very dynamic in the GATE exam. You need to be very quick in the exam. You need to be very precise in terms of time and lots of other things. So knowing the things, 60%, remaining 40% is your character, your personality, which will come into the picture when you will write the GATE exam. And that also you need to improve. If you haven't till now, you still have 1.5 months or more than that, 2 months. Improve that, improve problem solving and improve other things so that you can perform best in your GATE एग्जाम. चलिए आगे बढ़ते हैं, अगला क्वेश्चन सॉल्व करते हैं. अगला क्वेश्चन है ये रहा. ये भी बहुत इजी टाइप का क्वेश्चन था, बहुत इजी टाइप का क्वेश्चन था. ये इजी इसलिए है क्योंकि okay, so why this particular question is easy? Just because a single piece of information will be required and everything will be done. A main memory unit with a capacity of 4 megabytes is built using 1M cross 1 bit DRAM chips. Fine. Each DRAM chip has 1K rows of cells with 1K cells in each row. If you know that these rows of cells and some kind of structure, then you are clear about this kind of concept. If you don't know about this, then I will tell you once again that when a chip is manufactured, in the chip the cells are organized like this way, that there are multiple cells in the single row itself, and there are so many such kind of rows of the cells we will be having. This arrangement is why, just because we can perform refresh on multiple cells together. एक साथ multiple cells पे हम क्या कर सकते हैं? We can perform the refresh. And in one refresh time, how many cells are refreshed? This is a piece of information required for solving this question. वो है कि entire row can be refreshed in one time. Entire row can be refreshed in one time. So if I am saying that in the question it is given, that we have 1k rows of cells, and in one cell or one row, in one row how many cells are there? 1k. Then 1 kilo cells can be refreshed in one time. Given that the time taken for single refresh operation is 100 nanosecond, means you can easily understand in 100 nanosecond one entire row of 1k cells gets refreshed. Time required to perform one refresh operation on all cells in the memory unit is. चलिए पहले तो मैं आपको बताता हूं कि इसमें से क्या क्या इंफॉर्मेशन निकल जाएगी. फर्स्ट आई विल एक्सप्लेन एवरी सिंगल थिंग अबाउट द क्वेश्चन. आफ्टर दैट आई विल कम अप टू दैट पर्टिकुलर पॉइंट which actually I wanted to explain you, that if such kind of question comes, then you can save your time. You can save your time by targeting only the required information. रिक्वायर्ड इंफॉर्मेशन को टारगेट करके आप आंसर ला सकते हो. लुक एट दिस. वेट आई विल टेल यू हाउ टू सॉल्व सच क्वेश्चंस later on, but first of all I will tell you every information. Capacity is 4 megabytes. 4 megabytes means 4m cross 1 byte, or I can write as 4 mega cross 8 bits capacity I need, right? Now it is built using 1m cross 1 bit ka chip. So if this is the chip, how many number of chips are required? Can you calculate how many number of chips are required to implement this 4m cross 8 bit ka memory using 1 mega cross 1 bit? How many number of chips are required? 32 chips. 32 chips are required. Fine. चलिए आगे बढ़ते हैं. Then each chip, all the 32 chips will be having such kind of arrangement that 1k number of rows, and in each row 1k cells are there. Then time taken for one refresh operation is this. In one refresh operation, how many cells are refreshed? 1k cells are refreshed in which are there in the single row. एक row में 1k cells हैं. All 1k cells got refreshed in just one refresh operation, which is 100 nanosecond. So if I ask one chip का refresh time will be how much? One complete chip का refresh time will be how much? One chip refresh time will be equal to number of rows in the chips, number of rows in chip into one refresh time. This much. How many number of rows? 1k into 100 nanosecond. If one chip refresh time is this much, then 32 chips will take how much time to be refreshed? Same time. सेम एग्जैक्टली सेम टाइम उतना ही लगेगा. क्यों सर? 32 चिप्स को तो 32 इंटू ये लगना चाहिए ना. नहीं, एवरी चिप विल हैव इट्स ओन रिफ्रेश लॉजिक. हर एक चिप का अपना रिफ्रेश लॉजिक होता है जो चिप के साथ में आता है. So if you purchase a chip of DRAM, every DRAM chip individually can be refreshed. So all those 32 chips can be refreshed parallelly. All the 32 chips can be refreshed parallelly. So if that is the case, in that case one memory system, all 32 chips ka refresh time will be how much? Same to same, 1k cross or into 100 nanosecond. That will be the answer, that entire memory system will be refreshed in this much time only, which is option B. Now what I wanted to tell you is, if you know this information that all the chips can be refreshed in parallel, you will never calculate this information at all. आप ये वाला information calculate ही नहीं करेंगे, and that's how you can save the time in the exams. So you need to understand that what you need to calculate, and based on that you will just go with that information which is required. So you will calculate one refresh time, one chip refresh time this much. All the chip refresh time is exactly same. Number of chips निकालने का जरूरत नहीं पड़ेगा. I hope you guys are understanding this point simply. नहीं? Are you understanding this point or not? Are you understanding this particular point or not? I guess you guys are understanding this point clearly. Yes. So what I told, if you know that all the chips can be refreshed parallelly, you don't have to go with this calculation which is there in the green circle. Why? Just because you know that all the chips can be refreshed in parallel. तो नंबर ऑफ चिप्स कैलकुलेट करने की जरूरत क्या है? अगर नंबर ऑफ चिप्स है 10 या 15 या 20 या 16 या 32, कितनी भी हो, सब इतने टाइम में ही रिफ्रेश हो जाएगी. और इसके लिए आपको लगेगा नंबर ऑफ रोज इनटू 1 रिफ्रेश का टाइम. Okay, let me write a formula, the formula even more appropriate way. Number of rows into 1 refresh time. So here it is, the tip for you in the GATE exam. Read the question completely. If the question requires that you should calculate number of chips, then only you will calculate, otherwise not, so that you can save time, some 30 seconds, maybe 1 minute, and that 30 second 1 minute saved in 4 different questions can definitely give you more breathing space in a question which may require 2 extra minutes to be solved, and definitely it can give you 2 to 4 marks extra if you do such kind of things for multiple questions. All the chips can be refreshed parallelly. यही तो हमने कहा, इसलिए याद रखें ये चीज को. सारी चिप्स पैरेलली रिफ्रेश हो जाती हैं. चलिए अगला क्वेश्चन, सेम क्वेश्चन. आई ऑलरेडी सॉल्व. अमाउंट ऑफ रोम नीडेड टू इंप्लीमेंट अ 4-bit मल्टीप्लायर इज. मल्टीप्लीकेशन टेबल स्टोर करनी है. नाउ 4-bit का हाउ मेनी नंबर ऑफ रिजल्ट्स यू विल स्टोर. नंबर ऑफ रिजल्ट्स यू विल स्टोर इज इक्वल टू 2 power 4 into 2 power 4. And what will be the size of each result? Size of each result is equal to 8 bits, double of the size of input. So what is the size of ROM needed? 2 power 8 into 8 bits. Got it? 2 power 8 into 8 bits, which is 2 power 11 bits. कैसे किया? 8 is 2 power 3, which is nothing but 2 kilobits. D option is correct. Tell me if you understood this or not. I guess आपको कुछ भी प्रॉब्लम नहीं होगी इस टाइप के क्वेश्चन को सॉल्व करने में. I don't think so you will be facing problem of solving such kind of question. Already I explained you in just few minutes back. I already explained you this particular concept. ठीक है, आगे बढ़े आगे बढ़े आगे बढ़े. अरे आगे बढ़े कि नहीं रे बाबा, समझ रहा कि नहीं समझ रहा तू? चल आगे बढ़ते हैं. Another question. A ROM chip has a capacity of 1024 words of 8 bits each. This kind of chip you have 1K cross 8 bits. The number of 2 cross 4 decoders with enable line needed to construct 16K cross 16 RAM from 1K cross 8 RAM is. Now this particular question is having little bit more detailed understanding. First of all, let's calculate that how many chips are required and how those chips will be arranged. Why? Just because if you remember my point or my explanation in my classes when I told you that if you are going to implement or if you are going to use multiple chips in a single ROM chip or in a single memory system, then multiple chips can be arranged only in vertical manner or only in horizontal manner or in the hybrid manner. If we use the vertical manner, then definitely we use the decoders to access each and every chip, to enable each and every chip. Chip select lines to be generated from decoder. If you remember that, if you don't, then whatever I am saying, please understand that. So if you have vertically arranged chips, then you will definitely need the decoder. Okay, if you have only horizontal arrangement, you don't need any decoder. If you have hybrid arrangement in which vertical horizontal both are there, जहां vertical की बात आई decoder लगेगा ही लगेगा. Let's try to understand what will be the arrangement of the chips and how those chips will be arranged and what will be the size of decoder needed. Based on that size, we will go for the answer. First of all, number of chips. Let's calculate number of chips. How many number of chips required? Number of chips required is equal to 16K cross 16 divided by one chip capacity 1K cross 8. टोटल कैपेसिटी डिवाइड बाय वन चिप कैपेसिटी यहां से आएगा आपको 16 इंटू 2 32 चिप्स. These 32 chips will be arranged in this particular manner. 16 into 2 means you will be having two chips in a horizontal manner and such kind of 16 horizontal arrangements will be arranged in vertical manner. 16 such kind of horizontal arrangements will be arranged in the horizontal or in the vertical manner. Good. Nice. Abhi, if you remember the concept, well and good. If not, then you should have a decoder. That particular decoder should generate one output to select first entire horizontal arrangement, another output for another complete horizontal arrangement, similarly last output for selecting or enabling the last horizontal arrangement. Now you only tell me how many outputs to be generated from decoder if we are selecting one complete horizontal arrangement by one output. Two chips, such kind of 16 output, which means I need a decoder of 4 cross 16. I need a decoder of 4 cross 16. Now the question has been reduced to a digital logic problem that to implement 4 cross 16 decoder, how many 2 cross 4 decoders are needed? And the answer is 5. Answer is 5. How? 16 outputs you need? Yes. So 4 such kind of decoders will be arranged like that way. 4 output from each decoder. Yes. 1 2 3 4, 1 2 3 4 and 1 2 3 4. Now each decoder can have only 2 inputs here. 2 inputs. But here one decoder will be needed and that particular decoder will be selecting each of the decoders so that further level can generate 16 output. That's how. Okay, this particular concept completely you will understand in digital logic in more detail. But remember, to implement 4 cross 16 decoder, 5 decoders of size 2 cross 4 needed with enable line, and answer is 5. चलिए, I hope आपको ये समझ में आया होगा. I hope you got this particular point. Yes or no? समझ में आया या नहीं आया? जल्दी से बता दो, जल्दी से, quickly. Okay, if you got this point, then let's go further and let's try to understand the next question. चलिए, this is one of the amazing questions which I have seen in the GATE exam, just because this question needs your interpretation level to the highest possible level. एकदम प्रो लेवल का अंडरस्टैंडिंग चाहिए ओनली टू अंडरस्टैंड द क्वेश्चन. आफ्टर दैट यू विल ट्राई टू सॉल्व दिस क्वेश्चन. Okay, let's try to read the question first. After that, I will give you an example, and so that you will be able to understand the question and its analogy. And once you will understand the analogy, after that, definitely you will be able to solve the question quickly. Okay, let's try to understand. The main memory system that consider the main memory system that consists 8 memory modules attached to the system bus, which is one word wide. Okay, so we are having a memory system in which 8 modules are there. I will draw these modules: 2, module number 3, module number 4, module number 5 and 6 and 7 and 8. most of the students when they see the question they say अपने से तो नहीं बनेगा, ये अपने से नहीं बनेगा, छोड़ दो इसको, छोड़ दो। बट ऐसा नहीं करना है। गेट में ऐसे ही क्वेश्चंस तो आपको एवरेज लोगों से ऊपर लेके आएंगे। मैं आपको रेफर कर रहा हूं एज टॉपर्स, और वो रेफरेंस इसलिए है जस्ट बिकॉज मुझे उम्मीद है, आई हैव दैट फेथ इन योर प्रिपरेशन दैट समहाउ यू विल डेफिनेटली गेट इनटू टॉपर्स। सो आई एम गिविंग यू अ स्मॉल टिप दैट अगर टफ क्वेश्चन आता है तो उसे सॉल्व करने की कोशिश जरूर करें। ट्राई टू सॉल्व ऑल द टफ क्वेश्चंस ऑल्सो, just because all those members who have never studied or study very less, those members definitely leave such tough questions, and if you will be able to solve such kind of tough questions you will be in the toppers। चलिए आगे बढ़ते हैं। क्या बोलता है ये क्वेश्चन? क्या बोलता है? 8 memory modules attached to the system bus which is one word wide, so all these modules are attached with the CPU using the system bus, and the system bus, the data bus can carry how much data? One word. So data bus can transfer one word content from CPU to the memory system। चलिए आगे बढ़ते हैं। और क्या दे रखा है? When a write request is made, simple सी बात है, CPU generates read and write request for memory. So when CPU is generating the write request, what happens? Bus is occupied for 100 nanoseconds by data, address and control signals। अरे सिंपल सी बात है, if CPU is sending the write operation to the memory, of course CPU will send the address. Yes, CPU will send the data for writing. Yes, CPU will send the signal, control signal for the write operation in the memory. Yes, and through what CPU will send all these three things? By the system bus, right? So data of one word or data of some word will be sent by data bus, address will be sent by address bus, control signals will be sent by control bus, and that will be taking 100 nanoseconds। कितना टाइम लगेगा उसमें? 100 nanoseconds। Now what they say, during the same 100 nanoseconds, whatever the time they have given for 100 nanoseconds, this one for data, address and control signals, same 100 nanoseconds, okay, and 500 nanoseconds thereafter, और उसके बाद 500 nanoseconds, और after that 500 nanoseconds more, the addressed memory module, see, every single line, every single phrase is having a very deep meaning। The addressed memory module means among all those 8 modules, only that module जिसका एड्रेस सीपीयू ने जनरेट किया है, addressed memory module। Now I would like to call our addressed person from the crowd। क्या मतलब है? जिसको मैंने एड्रेस किया है उसको बुलाया है, right? So addressed memory module means for which CPU has generated the address, that module only, that module executes one cycle। What is one cycle? Accepting and storing the data। तो वो जो मॉड्यूल है 8 में से, among 8 modules, the module for which CPU has generated the address, that module will accept the data from this bus and will write that data into the memory system, but only that module, okay, and that will take how much time? 500 nanoseconds। The internal modules may overlap in time। What does it mean? Overlap in time means can be performed in parallelly। अब इन्होंने कहा है कि जो इंटरनल ऑपरेशन है, इंटरनल ऑपरेशन मींस वॉट एवर द ऑपरेशन ऑफ ईच एंड एवरी मॉड्यूल मींस दिस 500 nanoseconds का वर्क, दिस वर्क कैन बी परफॉर्म्ड इन द मेमोरी मॉड्यूल्स पैरेलली, but only one request can be on the bus। but जो 100 nanosecond वाला वर्क है, that 100 nanoseconds वाला वर्क which the bus is taking, that particular 100 nanoseconds वाला work will be done only one at a time। क्यों? Just because single bus is there, but the modules are 8, so multiple modules can perform that 500 nanoseconds वाला work in parallel। आगे बढ़ते हैं। क्या दे रखा है? The maximum number of stores, store is nothing but write operation of one word each, एक word का. Yes, my data bus is also one word wide. It can transfer one word at a time. Yes, and they are asking for one word writing only. There is no any problem. That can be initiated in 1 millisecond. एक मिलीसेकेंड में कितने राइट ऑपरेशन या स्टोर्स इनिशिएट हो सकते हैं? टू अंडरस्टैंड दिस पर्टिकुलर क्वेश्चन आई वुड लाइक टू गिव यू वन एग्जांपल. सपोज इफ I guess you all have gone for some kind of restaurants where first you will have to stand in a queue, you will have to place the order, you will have to take the order, after that you will place yourself in a table and then you will perform your eating like McDonald's or maybe KFC kind of restaurants. So let's assume such kind of restaurant, only single kiosk is there to take your order, take the money, give your food, and after that you will carry your food to a table and you will eat. Assume kariye there are 8 tables in that particular room. In that particular restaurant there are 8 tables. How many? 8. These 8 tables. Suppose if a person goes to a table with the food, that fellow takes 500 nanoseconds for eating. अरे वो fast है, I understand that, theoretically समझ लो. That fellow takes how much time? 500 nanoseconds for eating. Now I am asking a very simple question to you. If on one table one person sitting, on another table another person can sit and eat? Of course. Of course. Parallelly, total 8 people can sit on the table and can enjoy their meal. Yes. Now what I am saying is there is only one kiosk. There is only one kiosk through which the shopkeeper can take your order and can give you food, and that fellow is taking how much time? 100 nanoseconds for taking your order, taking your money also, and giving you food. So suppose so many members are standing in the line. Okay, the shopkeeper is checking out that yes, entire restaurant is free now, I can take the order. Yes, person will take the order. First order will be taken in 100 nanoseconds. Yes, after 100 nanoseconds, the first person in the queue will be getting the order and will go for this particular table. Suppose that fellow has gone for this particular table. Now this particular table is blocked for next 500 nanoseconds. Right? Means after 100 nanoseconds, 500 more means total 600 nanoseconds. This table is blocked. But do we have free table? Yes, we have free table. So restaurant is having a policy कि if any table is free, we can take the order, otherwise we will stop. हमारे पास अगर फ्री टेबल होगी तो ही हम ऑर्डर लेंगे, नहीं तो नहीं. So there is a free table. Yes, free table. Then restaurant owner will take the order. Another order will be taken in another 100 nanoseconds. Yes. So let me draw a particular such kind of timeline for you guys. Okay. So the person at 0 time, the person will take first order. First order will be taken at 100 nanosecond and first order is initiated. Means order is given, that fellow now will finish its eating at 600 nanoseconds. First order will be completed at 600 nanoseconds. But just because we have some other tables free, the person will take another 100 nanoseconds, and up to 200 nanoseconds the person can take second order also. Yes, second order will be initiated. That fellow second order will be completing after 200 plus 500, 700 nanoseconds. So second table is busy up to 700 nanoseconds in my timeline, and that second order will be completed. Now third order will be taken up to 300 nanoseconds, and that particular third order will be initiated in the 300 nanoseconds. अब आप टेबल पे तो बैठ जाओगे बट खा थोड़ी पाओगे. तो खाने के लिए आपको ऑर्डर तो चाहिएगा, ऑर्डर लेने के लिए 100 नैनो सेकेंड्स वो पर्सन लेगा, तो फर्स्ट 100 नैनो सेकेंड्स फर्स्ट ऑर्डर गिवन, यस दैट फेलो विल टेक 500 नैनो सेकेंड्स टू परफॉर्म द ऑपरेशन. Then after that, second order will be taken in another 100 nanoseconds. Just because second table was free, the person goes to the second table and that second table will be busy up to next 500 nanoseconds. Fine. Third order initiated, ये भी busy हो गया. Fourth order initiated, done. Fifth order initiated, done. Sixth order initiated. In first 600 nanoseconds, 6 orders have been taken and all the orders are on table number 1 2 3 4 5 6. Now if I am saying यहां पे fourth initiate हुआ, यहां पे फिफ्थ इनिशिएट हुआ और यहां पे सिक्स्थ इनिशिएट हो गया एट 600 नैनोसेकेंड्स, द सिक्स्थ ऑर्डर विल बी इनिशिएटेड. नाउ टेबल नंबर 7 and 8 still free, yes, along with that table number 1 also got free. Table number 1 also got free, means now 3 tables are free, table number 1 and 7 and 8. So can we generate another request? Can we take another request? Yes, another 100 nanoseconds required and we can take another request, 7th one. और तब तक 7th table is blocked but 2nd table is free, means up to 700 nanoseconds when we have generated 7 requests, among those first and second are completed, means table number 1 is free, table number 2nd is free, table number 8 is free. Once another 100 nanosecond required and then another request generated, 8th one, that 8th request will take how much time? 100 nanoseconds more, up to 800 nanoseconds. 8th request is initiated and now table number 1 2 3 are free. So every time a new request is generated, some kind of table will get free, means I guess you guys are understanding this point. I guess you guys are understanding this point. What am I saying is you can initiate one particular request in every 100 nanoseconds. So whenever you are generating a new one request, that particular one request can be initiated. Why? Just because every time you will be having a table free. Hence, if you come back to this particular memory operation, you can have the same analogy here, that this particular bus is nothing but that kiosk, that shopkeeper who is taking the order, and these 8 memory modules are nothing but those 8 tables. 8 tables. राइट. तो अगर 8 टेबल्स हैं आपके पास, इफ यू हैव 8 मेमोरी मॉड्यूल्स, देन among 8 memory modules at least 2 or 3 will be free every time. So every 100 nanoseconds the CPU can initiate one request. How many maximum requests can be initiated in 1 millisecond time is 10,000. Answer for this question is 10,000. So if you understand the question, look at this. This is the only solution required. Once you read the question and if you understand the question, then only this much calculation is required. That's it. So that's why I told you, if you have some kind of easy question, well and good. If you have such kind of tough questions, also read the question, try to understand the question. Might possible the question will not require much of the time after understanding it. सीखने के बाद, क्वेश्चन समझने के बाद हो सकता है क्वेश्चन को ज्यादा टाइम ना लगे सॉल्व करने में. चलिए, वी विल हैव फर्दर क्वेश्चंस. यस, वी हैव फ्यू मोर क्वेश्चंस. अ प्रोसेसर कैन सपोर्ट अ मैक्सिमम ऑफ 4 GB memory where the memory is word addressable. So every word will have one address. A word consisting of 2 bytes. So total capacity is this much and word is of 2 bytes. So how many number of words will be there in the memory? Number of words in the memory मेमोरी में टोटल कैपेसिटी 4 GB and each word of 2 bytes. So how many words you'll be having is 2G. So how can you represent the memory? You represent the memory like this. Memory will be of 2G number of words and each word of 2 bytes. Now what you need to do is the size of address bus of the processor is at least how many bits? 2G is 2 power 31 and based on 2 power 31 you should have address size at least 31 bits. Answer is 31. Very simple question this was. Very simple question. 2016 1 mark question. If such kind of question comes in the GATE exam, you will hardly take 10 seconds to read the question. After that 15 seconds to solve the question. Total 30 seconds, 1 mark done. Another question. Similar kind of question we have already solved previously. So I will now solve only required thing. A 32-bit wide main memory means whenever CPU wants to have an address over one address, CPU needs 32-bit ka content. CPU expects 32-bit content from main memory. 4 byte with a total capacity of 1 GB is built using this kind of DRAM chips. Fine. The number of rows of memory cells in DRAM chip is 2 power 14. So number of rows are directly given 2 power 14. Fine. The time taken to perform one refresh operation is 50 nanoseconds. Refresh time is given. Number of rows directly given. I don't have to calculate the number of chips here. Zarurat nahi hai. I already told you this. The refresh period is 2 millisecond. Oh, iska matlab kya hai? The meaning of this statement, refresh period 2 millisecond, means at 0 time, refresh operation is started. Refresh operation is started. So what happens? Some refresh time is required so that entire chip can be refreshed. And after that, remaining time will be used for read-write purpose. And from 0 to 2 millisecond, as soon as 2 millisecond is done, yes, refresh period is 2 millisecond, yes, once 2 millisecond is done, again refresh is started. Again refresh is started. Again refresh is started. So the question's answer should be what? What is the question they are asking? Percentage of time available for performing the read-write operation in the memory unit is. Total में से कितना time among total 2 millisecond kitna time is given for read write. So if we will calculate, or if we can calculate refresh time, subtract refresh time from 2 millisecond and you can get read write ka time and you can calculate the percentage. Okay, let's try to calculate one refresh time. One refresh time total, one refresh time means one chip ka ya pure chip ka refresh time. One refresh time is how much? See, one refresh operation taking 50 nanoseconds. So entire chip will take how much time? 2 power 14, which is number of cells or number of rows of the cells into one refresh time. ये मैं already explain कर चुका हूँ. Number of rows into one refresh का time. This much is the refresh time. Okay, if this is the refresh time, now there are two types of solutions possible from here. This particular paper 2018 I have written and I have claimed 440 rank in this particular paper 2018 में. 2018 में this particular 2018 में I have solved this particular question in the GATE exam and I got 440 rank. Of course, such kind of questions I was able to solve, and how I have solved this question I will tell you. So here there are two options. Either you take 2 power 10 as 1k, and 1k if you multiply in nano it becomes micro. So I have taken this, that 2 power 10 I have taken as k into nano, micro 2 power 4 16 into 5 is 600, 60 into 10 of course, 2 power 4 16 into 50 600, 600 होगा नहीं 800, sorry 800 microseconds, or in turn it is 0.8 millisecond. I have taken this 2 power 10 I have taken as around 1000, मैंने ऐसा लिया था. You can take 2 power 10 as equal to 1024 also, वो भी चलेगा, बिल्कुल चलेगा, वो भी चलेगा, बिल्कुल चलेगा, बिल्कुल चलेगा, बिल्कुल चलेगा. So if you will be taking this as 2000 or 1024 into 50 into 16, answer is 0.819200 millisecond. So either you take 2 power 10 as 1024 or you take 2 power 10 from here as 1000, you will be getting kind of this 0.8 millisecond directly or 0.8192 millisecond. If this is the refresh time, can you calculate what is the read write time remaining? Read write time remaining will be equal to 2 millisecond में से minus करो, 2 millisecond minus 0.8192 millisecond, and here it will be 2 minus 0.8 millisecond. So here it will be 0.11808 millisecond, and here it will be, I guess this will be, I'll do it, 2 minus 0.8129, 0.1, sorry, my bad, it should be 1.1871, and here it should be 1.2 millisecond. Okay, so little bit calculation here and there, and now fine. जी नहीं, ये लास्ट वीडियो नहीं है, अभी तो काफी सारे वीडियो बचे हुए हैं. Right now, if read write time is this much, how much percentage is this of 2 millisecond? So if I'll calculate percentage of read write time, it will be equal to how much? It will be equal to this much, 1.1871 divided by 2 into 100%, and here it will be 1.2 of 2 into 100%. Here you will be having nearest integer 59%, here you will be having nearest integer 60%. Now nearest integer 59%, nearest integer 60%. Now you could have gone with any option. They have given in the range answer, they have given as 59 to 60. If you could have gone with answer 59, that also was correct, 60, that also was correct. Now I have gone with this one. Why? Just because I know gate in and out a lot. I have written the gate exam multiple times. I am teaching for gate since last 10 years. I know that they can take this 2 power 10 as 1000. Based on their calculations, I have seen it. Easily you can convert this. कोई problem नहीं होगी. I have gone with this. Without calculator, I got 60% answer. Without calculator, I have got 60% answer. So आपको ये समझना होगा हमेशा कि it's not always the conventional way you will solve the question or you will use calculator or something. Without calculator also you could have gone the correct answer with this 60% also. Got it? Understood? All the members जिन्होंने बाद में ज्वाइन किया है, सब लोगों से एक सिंपल सी रिक्वेस्ट है, क्या आप लोग इस सेशन को लाइक कर सकते हैं? प्लीज लाइक दिस पर्टिकुलर सेशन. अनदर क्वेश्चन, अ चिप सिलेक्ट लॉजिक for a certain DRAM chip in a memory system design is shown below. So chip select के लिए ये डिजाइन दे रखा है. If this diagram is not visible, this is A15, then A14, then 13, 12 and 11. Assume that memory has 16 address lines. Okay, so denoted by A15 to A0. So 16 lines are there. A15, A14, A13, A12, 21 लिख दिया मैंने, A12, A11, A10 and up to A0. These are the 16 lines. What is the range of address of the memory system that can get enabled by chip select signal? हमें chip select signal के through we need to enable this particular chip. Look at this. This chip select signal is taking these 5 bits, A15 to A11. remaining bits will go as address. So these 5 bits we should use for chip select, and this chip select logic saying what? I should have this A15 given directly. This big D, whatever is visible here, it's a big AND gate. हमें इस एंड गेट के थ्रू इस चिप सिलेक्ट को इनेबल करवाना है. मींस एवरी इनपुट शुड बी enabled. If every input should be enabled, of course A15 should be 1 directly going into the gate. A14 should be 1. A13 should be 0. क्यों? अरे ये गोला किस लिए है? This particular circle is for not. So if we will be having A13 0, 0 का not 1, and enabled signal will go to AND gate. Then A12 also 0 and A11 1. We should keep these 5 bits 1 1 0 0 1 only, so that this chip select can be enabled. अगर chip select enable होगा तभी तो chip select होगी. Now 1 1 0 0 and 1, and remaining bits you can have from all zeros to all ones, but these bits should be this only 1 1 0 0 1. Addresses we are able to achieve here. This is C, yes. Then 1 0 0 is 8, then 00. Then this is C. 12 is C. Then 1 1 1 1, which is F. Then 1 1 1 1 F, 1 1 1 1 F. This is the range of addresses I can access using this particular given understanding or this chip select logic. So C800, C FFF, answer is A. That is the range. चलिए आगे बढ़ते हैं. कुछ और क्वेश्चन बचे हुए हैं, फिर सेशन खत्म हो जाएगा हमारा. आई गेस लास्ट क्वेश्चन फॉर द डे. इफ देयर आर m input lines and n output line is used to uniquely address a byte addressable 1 kilobyte RAM. So byte addressable 1 kilobyte RAM means 1 kilo cross 1 byte ka RAM you are having, right? If you have such kind of RAM, then to select each and every cell we will need a decoder. इंटरनली डिकोडर लगता है एड्रेस डिकोडिंग के लिए. एड्रेस डिकोडिंग के लिए देयर इज अ डिकोडर needed, and this particular decoder will enable or will go to the first cell with first output, similarly to the last cell for last output. This particular, how many cells you have? Number of cells is equal to 1k 2 power 10, और हर एक सेल पे 1 byte. So what should be the decoder size? Decoder size will be 10 cross 2 power 10. So what is there? How many inputs are there in this decoder? Number of inputs, 10 inputs. So m inputs, m is equal to 10. N output, 1024. What is asked? M plus n, 1034. $1,034 will be the answer for this question. This was one of the easiest question for memory addressing. 2020 gate 2020 question. It was very easy, very easy. चलिए तो ये सेशन आज का हो गया खत्म. आज हम और क्या नेक्स्ट पढ़ने वाले हैं. 4 PM पे देर इज अ स्पेशल क्लास ऑन अनअकैडमी. इफ यू गाइज आर नॉट ऑन अनअकैडमी, गो ऑन अनअकैडमी's platform. Today free special class I am going to take, and this particular free special class is about 2013 and 2005 के gate questions. ये क्यों स्पेशल है? जस्ट बिकॉज दीज हैव बीन आस्क्ड इन IIT बॉम्बे प्रिपेयर. So 2013 and 2005 के gate questions on the special free class on data structure course. Only data structure. Already we have covered COA questions in the special classes. Today data structures. And then 7 PM we are going to have the YouTube sessions which could not happen yesterday, and this YouTube session we are going to have about binary search tree data structure. So on Unacademy. If you want to come and you want to learn for free, come, join karo. Search my name, Vishwadeep, and follow my profile. You'll get notification of all my special classes, all my free classes, and you come and learn for free. If you need for the first time to unlock the special classes for free, then you can use this particular code VD10. ओके, चलिए आगे बढ़ते हैं। ये है आपका और सारी इंफॉर्मेशन। ये है हमारी टीम जो आपको पूरा सपोर्ट कर रही है, आपको फ्री एजुकेशन, क्वालिटी एजुकेशन प्रोवाइड करने में बहुत 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 ज़्यादा हेल्प कर रही है। इस पर्टिकुलर टीम को आपको सारे अपने कलीग्स, फ्रेंड्स सबके साथ शेयर करना है। इस पर्टिकुलर टीम में जितने भी मेंबर हैं, उन्होंने कहीं ना कहीं किसी भी एग्जाम में कुछ ना कुछ टॉप किया हुआ है, चाहे वो गेट है, एनईटी है या कोई पीएसयू एग्जाम है, कुछ ना कुछ क्रैक किया हुआ है एंड दे आर हैविंग 10 years एक्सपीरियंस मिनिमम एवरीबॉडी। सो यू रिलाई ऑन टीम। और इस पर्टिकुलर टीम के जितने लेक्चर्स हैं, सब लेक्चर्स को आपको पढ़ना है, इन प्लेलिस्ट को आपको पढ़ना है। देखिए, डिस्क्रीट मैथ की प्लेलिस्ट है आपके पास, टीओसी की प्लेलिस्ट है, सीओए की, मेरे डेटा स्ट्रक्चर की भी प्लेलिस्ट है, कंप्यूटर नेटवर्क की भी है, ऑपरेटिंग सिस्टम की है, मशीन लर्निंग की प्लेलिस्ट है, और भी बहुत सारी प्लेलिस्ट हैं इसी चैनल के अंडर में। तो इस कंप्लीट पैकेज को आपको सब जगह पे फॉरवर्ड करवाना है, सब जगह। जितने भी स्टूडेंट्स आपके साथ कनेक्टेड हैं, जो सेमेस्टर या फिर किसी भी ना किसी एग्जाम के लिए कंप्यूटर साइंस पढ़ना चाहते हैं, उन सब के साथ ये सब शेयर करना है आपको। इसके साथ ही साथ अगर आप चाहते हैं कि आपको इन लेक्चर्स की पीडीएफ मिले, तो आप ये अनअकैडमी गेट सीएस नाम का एक टेलीग्राम चैनल है, ज्वाइन कर लो। यहाँ पे आपको अनाउंसमेंट और सारी नए जितने भी हमारे इनिशिएटिव होने वाले हैं उनकी इंफॉर्मेशन मिलेगी, प्लस लेक्चर के पीडीएफ में मिलेंगे। एक और बड़ा अनाउंसमेंट मैं करने जा रहा हूं कल शाम में 8 PM पे, 8:15 PM पे आई एम गोइंग टू कम लाइव एंड आई एम गोइंग टू गिव यू अ बिग न्यू इनिशिएटिव। यस, जी हाँ, हम लोग बहुत कुछ लाने वाले हैं। उनमें से क्या लाने वाले हैं, ये 8:15 टुमारो इन दी इवनिंग पता चलेगा आपको। इसके लिए लाइव इवेंट और पोस्टर्स और बहुत सारी इंफॉर्मेशन हम लोग बहुत जल्दी आपको प्रोवाइड करने वाले हैं। सो स्टे कनेक्टेड विद अस इफ यू वांट टू बी कनेक्टेड विद मोस्ट ऑफ द स्टूडेंट्स, विद ऑल ऑफ द एजुकेटर्स, और हमारी टीम के साथ कनेक्ट होना है, तो ये फेसबुक पेजेस हैं जो आपको हमसे कनेक्ट करेंगे। इसके अलावा अगर आपके कोई भी फ्रेंड दूसरी ब्रांचेस में है, इलेक्ट्रिकल, मैकेनिकल, सिविल, इलेक्ट्रॉनिक्स, किसी भी दूसरी ब्रांच में, किसी भी दूसरी ब्रांच में, किसी भी दूसरी इंजीनियरिंग फील्ड में, किसी और एग्जाम की प्रिपरेशन भी कर रहे हैं, तो वी हैव एवरीबॉडी हियर। सबके लिए चैनल है हमारे पास। इलेक्ट्रिकल ECIN के लिए क्रिएट्रिक चैनल है, रिकमेंड करें उन्हें ये देखना। मैकेनिकल के लिए चैनल है, सिविल के लिए चैनल है, तेलुगु लैंग्वेज के लिए चैनल है, SSC JEE के लिए चैनल है, GS टर्मिनल है जो जनरल स्टडी में, हम जनरल स्टडी के जितने कोर्सेस हैं उसके लिए है। कंप्यूटर साइंस का चैनल है जो आपका अपना ये वाला चैनल है। अगर आपने इसको सब्सक्राइब नहीं किया है तो अभी करें, और साथ ही साथ जितने भी आपके फ्रेंड्स हैं सबको ये चैनल्स के बारे में ज़रूर बताएं, ताकि वो सब भी हमसे कनेक्टेड रह के और क्वालिटी एजुकेशन ले सके। एवरी टाइम यू कम हियर, प्लीज़ लाइक द सेशन, शेयर कर दिया करो सेशंस को अपने सोशल मीडिया, अपने ग्रुप्स पे। प्लेलिस्ट कोई अच्छी लगती है तो उन्हें शेयर कर दिया करो। प्लेलिस्ट अगर बहुत ज़्यादा अच्छी लगती है तो उस प्लेलिस्ट के फर्स्ट वीडियो पे जाके और उस पर ज़रूर कमेंट करें, ताकि आपके हमें फीडबैक मिलते रहें। सब्सक्राइब कर लें चैनल को अगर नहीं किया है तो, और नोटिफिकेशन ऑन करके रखें ताकि आपको मिले सारे नोटिफिकेशन जब भी हमारी क्लासेस आती हैं। माय फेवरेट कोट, ऑलवेज हैप्पी लर्निंग, कीप लर्निंग हैप्पीली। थैंक यू सो मच फॉर डेडिकेटिंग योर टाइम हियर, थैंक यू सो मच फॉर ज्वाइनिंग अस हियर। नेक्स्ट सेशन भी ज़रूर अटेंड करें। हम वापस मिलेंगे आपसे, तब तक के लिए थैंक यू सो मच। हैव ए नाइस रिमेनिंग डे, बाय बाय।